everybody, Amy Williams and Kiara here from Skellig, and welcome to the final episode of our 5-part series. Today we are doing the walkthrough of our demo Life Science Greenfield Unified Namespace facility. In the previous video, I introduced the architecture and explained what everything's role is and what it's doing behind the scenes. If you haven't seen that video yet, I highly encourage you to watch that one first, because today is going to be different. We are shifting completely to the front end. We are going to be viewing the UNS from the perspective of the end user. Think operator, scientist, manager, etc. And we're doing that because Skellig has done UNS demos before. We've presented to an intelligent audience who understood the architecture. They got that everything was connected, but the conversation still ended with, why would I want this? It looks just like the DCS system I have. And they're not wrong. It's true. Whatever your traditional 3.0 architecture does, that functionality can be recreated to a T with a UNS. But I think where we failed in the past is we didn't show that there are use cases a UNS can solve that a 3.0 architecture cannot. And I'm not even talking about the obvious ones of 4.0 tech of AI, machine learning, cloud computing. No, I am saying even at the plant floor, when you first start, there are use cases that you can address that historically a 3.0 facility never could. Today, we're going to see a plant run a batch. It's a classic life science example we've all experienced a million times. My role is to point out to you why this batch is different. Why people who couldn't care less about message protocols, data models, systems architecture will want to work at a UNS-based facility. With that said, let's go check out this demo. Hey everybody, welcome. Glad to see you were able to badge in just fine. Now, the first novel aspect of this 4.0 facility that I want you to notice is the entire tour is going to take place in a web browser, not a variety of applications. Everything for the end user can be viewed from a Windows machine, a MacBook, a tablet, a phone, you name it. Anything that can connect to a web browser. Talk about convenience for the employees. That's going to lead to an increase in response time and massive cost savings for this facility, because we don't need to buy heavy-duty, expensive physical computer workstations for the plant floor. No, we're going to use GMP tablets. Now, speaking of the plant floor, let's take a look at it. This is the overview screen of our plant. It was created with Ignition's perspective module. Something you're going to notice during this tour is that it's going to be viewed through the lens of Ignition's perspective module. And that is completely because of my personal preference. I happen to like the perspective module because it's a lot of drag and drop. I don't need to know HTML to build a web page. And that's the beauty of a UNS. Even though we're using data from lots of different systems, I'm able to pick what software I want to view it. And in this case, I happen to like Ignition. So far, we only have the one bioreactor. If I click this, I come on over to my HMI screen. Now, because this is a free demo, we kept it simple. If you want your HMI to look very different, don't worry. There's almost no limit to what you can do with Ignition. I promise you could build it how you like. But for today, we have equipment modules in the lower right-hand corner. And we also have control modules up here with a nice little faceplate where if you open it up, you can click on whatever parameter you want to see historical trending. And we also have alarms up in the corner where we can click on that and get a classic alarm table. Kepware is being used to simulate our IO values. However, the actual unit itself is being controlled by Codesys running on a Groove Epic. At this point, hopefully this looks pretty standard and feels familiar to the operators. Now, even though it might feel the same as a traditional plant, there is a vast difference in how this data is structured and connected. The best way to showcase this is to generate some data by running a batch. Let's hop over to our Sepasov batch module. Notice, because this is for Ignition, I can access this seamlessly from the web page. We'll just come over to the tab and click our batch. Now, I'm going to give you a quick tour so you can see how easy and functional this module is. The first thing that I want to show is that this batch module adheres very closely to ISA 88. So we can come down to the manager, and you can see that when you add equipment, it has to go enterprise site area process cell unit. In addition, over here, we have the unit class with phases assigned, and you're going to see that recipes work the same way. They are unit class based, and then inside the recipes, you got your unit procedures, operations, which contain your phases. You can also make parameters and defer them as needed. Okay. All right, with that said, let's go ahead and load up a batch. All right. Cool. What just happened is the Sepisoft batch engine is telling Codesys running on the Groove Epic to start the sample phase. I'm going to show you that now. What we have here is a web page based manager that you can access to see your Groove Epic configuration. We can come over to controller, and if we click on it, we can see that we do in fact have Codesys running. Now, the next thing that I want to do is go ahead and actually open up Codesys just to show you a few things. Somebody might be saying, hold on, I thought you said our end users are going to access things through web browsers. What's up with this application? Don't worry. I think that it is completely fine that Codesys is an application that is hard to get to. I don't know about you, but I do not want my average users accessing PLC code. Instead, if my users want to view any data from that code at this facility, they're going to do it through a view-only screen through Ignition. Remember, we have Codesys running on the Groove Epic with Ignition Edge, so all of its data is being published to the UNS. The whole reason that we're taking the detour to look at the application is for two things. Number one, I want to prove that this is actually running on a Groove Epic. And number two, I want to show that Codesys is a robust PLC programming language. It has all of the IEC 611313 languages. Some of the popular ones are ladder logic, function blocks, some sequential function charts. I think we even have our phase up and running over here. And if we double click on our run logic, you can see that we actually also have structured text for its functionality. It's also worth mentioning that for version control, you can use Git. Now, the thing is, the end user, your process engineer, your operator, they won't notice the difference if you use Codesys versus some really expensive control software. What they will notice is needing to log in to multiple applications and at physical HMIs and workstations to do their job. Not only that, but your managers and directors will notice the crazy licensing costs for the multiple applications and workstations and infrastructure for those traditional control systems. At this facility, our Codesys data is being accessed, modeled, and published to the UNS within the Groove Epic. Our end users don't even know about Codesys, and I like it that way. We should be simplifying what our operators interface with. Whatever they need to access at this plant, they're going to do it from the web browser. Circling back, let's go look at our batch. While your batch is running, what's cool is Sepisoft comes with a tab called Batch Controller. So if you need to change the mode of your recipe and send it any commands, you can do it here. Or if you just want to check out your batch without risk of stopping it, you can come over to the batch monitor where we can see all of our recipe parameters and see what's running. And of course, you can configure only certain users to have certain access based on their roles. All right, let's jump back over to our unit. And we are prompted to take a sample. At this theoretical site, our operator will take a sample from the bioreactor and then bring it over to a cell viability analyzer to then test it. A 3.0 facility normally does this part wrong. When the employee takes the sample to the lab equipment, that data usually just stays within that equipment's closed system. If they want to see that data anywhere else, they will discreetly share it by generating a report and emailing it, or go through the painful effort of discreetly engineering and validating a connection into one other system like their DCS system. Our 4.0 facility is approaching this differently. Instead, we used a custom driver to expose the raw sample data value, and with Ignition, we model it and use the unified namespace for contextualization. This approach is much better, and I'll show you why. For instance, our operator is able to use a GMP tablet. So they can bring that with them over to their lab equipment to take the sample. And they're going to do that. They're going to trigger the sample within the same browser just by going over to the lab tab. This brought us to a paper on glass data entry form. The operator hits sample on this form, which triggers the lab equipment to analyze the bioreactor sample. This is possible because this facility is using custom drivers to enable data access and communication from the lab equipment into the UNS. It's worth noting that data is still going into its local LIM system. For the record, this isn't theoretical. Skellig has done lab digitization projects completely devoted to building these custom drivers to connect to all sorts of weird equipment. And I say that to be motivating. Do not settle for data silos. When you buy lab equipment, put pressure on the vendor to give you unrestricted data access. And if they can't do it, go find a driver or build one yourself. It can be done. Now, sadly, we don't have an actual cell viability analyzer lying around. So when we hit sample, we're actually simulating a random value, which populates the raw value and sample type. Because this is a digital form, not a piece of paper, this form is connected to the unified namespace and is able to pull in data to build context. Let's look at some of the fields. The first thing is we have the unit, and then notice the batch ID is being pre-populated, even though that was defined over at the Sepasoft batch engine. The next field is the lot number, which is being pulled from our ERP system. Remember, that's simulated, so that value is down below. And if needed, we can add a comment. For the end user, this form is already pulling in context. There is no need for them to have access or logins to the ERP, batch engine, LIM systems, or even a clock to fill this out. Instead, it's digital. There's no room for manual transcription errors, and it's real time. All the end user has to do is hit sample, add a comment if they like, and then electronically sign for it. Awesome. Let's go back to our HMI, which again is the same web browser from our tablet, and end the phase. And there's one last thing that I want to show you about the Sepasoft module. It actually makes a beautiful batch report, and it looks a lot like the ones we're used to seeing. We have, the unit procedures, the recipe parameters, and the electronic trail of who answered what prompts when. Even though our batch is over, we actually have some more use cases to go over that can help the end user. Now, if we come back to the HMI, remember our little faceplate here? This guy is actually displaying historical data from Canary. This might look similar to what you've seen before, but I promise it's actually quite different. In the 3.0 facility, my historian was manually linked into every tag within that control software. To view the trend, you either viewed it within that control software or within the historian. This is different. I'm not using Code Assist to visualize this data. In fact, I'm not even using Canary to visualize this data. By the way, Canary does come with its own web-based trending called Axiom, which is great. I have nothing against it. But for this use case of a faceplate, I wanted to use Ignition. And that's the power of a UNS. Data can be used by any nodes that are connected, which lets me pick the best application for the specific use case. Now, it gets even better. If I double click on my trend, I am brought to my big trend page. Canary is historizing from my UNS. It not only has my CODISYS data, but it also has the lab data. So if anybody wants to see how does lab data of nominal concentration trend against DO, I can view these both no problem. Again, no need for multiple logins to a LIMS system, to a control software. Anyone has read-only context and access at their fingertips. Now, we can gain more insights from our data by using a data analytics software like Flow. From my browser, we can click the Data tab, which brings us to Flow's web page-based display. If I wanted, I could create a visualization in Ignition that uses all of the calculation and models created in Flow because that's an open software. It likes to share. But I happen to like Flow's out-of-the-box chart components, so I use their web page here. Again, great thing about being open means the end user ultimately has the choice and the options. Let's explain what we're looking at. In the upper left-hand corner, we're displaying a list of the batches for our unit. We have start time, end time, whose source was the Sephisoft batch module. Then we have the lot number, sourced from the ERP simulation. And we have calculations of efficiency per batch done by Flow. I kept it simple. It's just run duration divided by total duration of the batch run. Over on the right, we have a chart that graphs this efficiency over minutely intervals. The point of these two objects is to give any end user a quick insight into how the batches are running. Think shift leader, manager, engineer. And I think that is so incredible. What's wild is during my entire process automation control career, I have never seen a screen for efficiency, let alone full-on OEE. It probably existed somewhere. Maybe it was on the to-do list for the MES group, but since OEE isn't on the FDA's pre-requirement list to validate your process, who knows if they had time to get to it. My guess is maybe at these sites it existed in an ERP system or private Excel file that got shared amongst directors. Regardless, what's crazy is that there was an entire automation department who showed up every day, provided on-call support every night, with the sole goal of helping those operators keep that efficiency number as close to 100 as possible, and they had no clue how it was going. And that comes back to the weird 3.0 characteristic of hiding data. Information being restricted to the end users, probably because of the bureaucracy and risk associated with giving everybody multiple user accounts and syncing up all these accounts together. And that's unfortunate, because the automation team would get contacted with, oh, night shift said last Tuesday a batch held because of something. And then we were the ones who would have to spend hours poring over electronic batch reports just to try to identify what happened and when. We're not even talking about fixing the problem yet. And don't get me wrong, I'm not hating on digital batch reports. In fact, this 4.0 plant still has them. I showed you the Sephisoft batch module because they are a requirement for life sciences. They provide that FDA mandated traceability. But let's be honest, it is hard to quickly glean information from them. They are great if you can pinpoint where to look, but absolutely terrible as a starting point. That's where a dashboard like this becomes valuable. Your engineers, operators, shift leaders, they don't have time to thumb through pages upon pages of batch reports, but they do have 15 seconds to quickly scan a dashboard. Here's how this one works. With the table on the left, we're building context from different sources and giving a quick overview of batches that went well and whose didn't. However, if your total efficiency is 75%, that one number doesn't give you the full picture. Batches normally take days, so if you pair it with a minutely graphic, you actually get a better sense of how did it go. Was it a constant struggle so efficiency hung around 75%? Or was it going great and then something happened at 3 a.m. so it dropped and then it came back up? Knowing which scenario it was enables your shift leaders, managers, engineers, whoever, to pinpoint where to start an investigation. At this facility, I'm using Ignition and Flow to view process data from my UNS. Both of those are linked to Active Directory and are accessible via a web browser. So any work that goes into making data into understandable information is going to be accessible to everyone and beneficial to everyone with minimal cost or risk. So we just covered how these top two components help you understand what happened. What's really cool is the bottom one will help you understand what will happen. So the solid line is the PV of our bioreactor's temperature, and the dashed line is Flow's engine predicting out 3 hours what the PV will be. This is awesome. Normally, your 3.0 plant forces your operators to always be reactive. Only when something hits the alarm do they get the notification to take action. And in life sciences, that's a huge problem. We can't just run out there to see what's going on. By the time you get to the locker room, put on the bunny suit, wipe down your phone, badge in the hallway, badge in the clean room, put on the second layer of gowning, it's easily been 20 minutes and your warning alarm has now escalated to critical. For better or worse, because we have shifted to single-use technologies and mobile equipment for plug and play, proper troubleshooting often needs at least one person out there on the plant floor to see what's happening. That is why it is so much better to be proactive. At this plant, Flow is predicting out our critical process parameters, and if an hour from now they're outside the high or low alarm limits, Flow is going to send a remote notification to a proper user group via text, Slack, or email. This way, if you're at your desk or not even at site, you have time to start investigating before something becomes a deviation, you need QA, or heaven forbid, risk losing a batch. And of course, besides predictions, Flow is great at help finding golden batches. You can make those benchmark KPIs of runtime, hold time, number of holds, and because we are using the UNS architecture, those KPIs can tie in raw material costs and quality info like yield. Moral of the story is the power of a 4.0 facility is that you can easily access data, which enables your end users to do their jobs more efficiently. What I want to do now is show how that works a little bit in the back end for our UNS. So I made a little page over here called UNS, and this just shows how in this demo we can use MQTT to combine different namespaces together to form my master unified namespace. So the first namespace up here on the top is just the data associated with the Sepisoft batch module engine. As you can see, all it knows is batch phases and batch details. Doesn't have a clue about I/O, and that's fine. The one in the middle is our traditional Ignition engine, so it has all of our CMs, EMs, and some stuff for visualizations. And then down here at the bottom is our lab digitization, lab sampling data. And all it knows is stuff about the sample. Now what's happening is all three of these are publishing to my master broker. And if we expand the one on the right out, you can see that it combines everything. So let's take note of one in particular. Like I said, the Sepisoft batch module is awesome. However, out of the box, it didn't have a tag specifically for my active phase. Instead, all the phases are listed with their state if they're running or not. I wanted that tag. So in my Ignition namespace, I made that tag. And what's cool is I'm able to publish that to the same topic of batch details. And over here on the right, you can see that it combines. We also happen to have that lot number information, which is being published, simulated from the ERP. Now, the last thing I want to talk about is scalability. This architecture scales because nothing was discretely connected. Engineering effort was put in the first time to get all my systems connected to the UNS, but that was a one-time effort. Since everyone is subscribing to my broker, they will immediately have visibility to new equipment as it comes online. No additional engineering effort is required. But of course, your systems have to do more than look at data. They got to do something with it. And that comes down to structure. Because the data in our unified namespace is structured, the back end can be designed very dynamically. Nothing was hard-coded specifically to the STR200 on the Groove Epic. Rather, everything we saw today functionally was designed dynamically off the structure of the UNS. If we add more equipment, everything will still work with little effort for the new equipment. For my Delta V friends, it's like instantiating an instance of a class, but for your whole plant. Now, a bonus with Ignition is that it allows you to do scripting. That means you can automate this instantiation process, and you're going to see that. But I want to make this crystal clear. Scripting is cool, but it's not a requirement for a UNS. The requirements are open, edge-driven, lightweight, and report by exception. If when you scale, you add more equipment, your solution requires clicking a button to instantiate, but you still have no discrete connections, that's a scaling solution. That's a win in my book. Now, speaking of scalability, let's go ahead and add some equipment. And to do so, I'm going to need a volunteer. Just kidding, she's sleeping. And besides, I have a bonus cat. Little Nala right here is going to name the second reactor being added to our facility. STR. All right, little baby. Beautiful. Oh, thank you so much, Nala. Okay. So as you can see, our unit defined by Nala is already here. And I jumped the gun. I actually wanted to add 2 more units before doing this. So we're going to add those really quick right now. We're going to go ahead and add 1 more unit and another one. So what this is doing, this little button here, this is a script that essentially makes a new instantiation of a UDT. What we're doing is we're simulating plugging in 3 more Groove epics that are publishing structured data into our UNS. Awesome. So now if we refresh, we can see all of our new units are here, which is great. So let's go check out how our plant looks. If we come back to our overview screen, you can see now we have the 4 units. So let's click on STR201, and you can see we have an HMI. Now, maybe you're looking at this and you think, this looks a lot like STR200. I'm not that impressed. In my traditional DCS system, I can take a graphic, do Control F, replace, and have the same thing up in 5 seconds. Why would I want this? I didn't go faster than the speed of light and build a duplicate graphic. This is the same window. The configuration of my software version has not increased. So that's really powerful because I just bypassed the need to update a design spec, a test protocol, include validation and QA to get that released and move to production. Of course, I'm probably going to have to update some design spec for my unified namespace documentation, but the graphic design spec, that hasn't changed in my book. My window was never hard-coded to STR200. It, from the beginning, was validated to just point to my unified namespace. So even though we added essentially a duplicate reactor that's only named different, it's able to display that with no additional cost or effort required. Talk about scalability. What's even better is this still applies even if your equipment is slightly different. That's why I let Nala name one of the reactors. My little script basically said, if STR2 something, instantiate this UDT. If it's not, kind of instantiate a random one. Very cool. Now let's actually see if this crazy unit runs. So we'll go back on over to the Sephisoft batch engine, and we're going to load up a recipe. Now you can see all of my units are here, so they were correctly assigned to our unit class. We can load it up and click play. Again, we have to go back to the HMI where we will be prompted to take a sample. So that means once again, we have to jump back on over to our paper on glass form. We are back. What's cool is because this is built with Ignition, this form is also dynamic. We are pulling in the unit and the batch ID. There wasn't a lot number simulated yet for this unit, so we're going to simulate one right now down here. Again, pretending it's from the ERP system. And then what's cool is you can see that even if I go back to pick SCR200, this form is pulling in its associated data from the unified namespace. Great, so let's go ahead and click sample, and we will sign this. Let's go back to our HMI and answer the question to end the phase. And again, we can toggle between units, 200, 201, the cat unit, and we can see that the batch ID below will populate. And I guess over here, the cat unit only has one pump. So pro tip, don't let your cats design your bioreactors. And what's really great is Canary is historizing all of this with no effort required on my end. It's just subscribing to that topic. And as far as flow goes, it's really easy to instantiate those models for other units. Everything I built in flow is using attributes that are going to be common across all pieces of equipment. I don't care if it's Rockwell, Siemens, Delta V, Codices. The batch ID information of start time, end time, runtime, hold time will be the same, so that model of analytics will scale. All I have to do is instantiate and I'll be good to go. To wrap up, today you guys saw a bunch of use cases to really hammer home the advantages of why it's so great to have a unified namespace. But I would love to hear a comment below any use cases you think you could solve with a unified namespace architecture, or even if you're working on something right now, I'd love to know. Because the thing is, accessing your data in a very intuitive way will benefit everybody. From the employee who saves time by not having to log into 10 systems, to the other one who's able to get context to solve problems faster, to the end patients who benefit from having more manufacturing, more treatments, more therapeutics available on the market. And of course, the icing on the cake is building this is faster and more scalable than the traditional 3.0 discretely connected architecture. All in all, I hope you guys really enjoyed this demo series. We had a ton of fun with it, and thank you so much for your time. I really appreciate it.